Hello, Algebra 2 folks, and welcome to Math is Radical. We are going to start by doing radicals and rational exponents this chapter, but we need some exponent rules review. So if you take out the foldable that I gave you and cut it up so it looks like this when you fold it all up, notice, you cut out the, where it says cut those out, and then you should be able to fold them over. And this is the outside. And it just talks about all the different rules that we need to go through. This is your organizer. And then when you open it up, you'll put the examples on the inside. Okay, but before we start, we're going to start with this basic one here. And I just want to reiterate what the x represents. That's the base. Okay, so write that down. And then the 4 we would call the exponent. Okay. So this is what the outside of the foldable should look like. And then you should be able to glue it into your notebook or tape it into your notebook when we're done. All right, so now when you open each section, when you open them, you will see the different sections, and we're going to go through each one of those sections. So the first one we're going to open is that x to the 4th, where we talked about the x is the base and the 4 is the exponent. X to the 4th means multiply x by itself 4 times. So this is what you would write. X times x times x times x. X to the 4th means multiply x by itself 4 times. So x to the 1st and x to the 1st and x to the 1st and x to the 1st. That would be x to the 4th. Okay, let's open the next one. Okay, now we're going to go to the product rule, the one right underneath of it. Okay, notice I'm going to go down the page and then I'm going to go back up and then down again. All right, so when multiplying things with the same base, we can add exponents. Okay, so that is the product rule. So right now we're talking about the product rule. So the product rule, let me write this right here. So you know where we're at. When multiplying things with the same base, you can add the exponents. So x to the 2nd times x to the 3rd would be x to the 5th. Okay, so my question is why? Well, here's why. X to the 2nd means take x times itself twice. X to the 3rd says take it times itself 3 times. How many x's do you end up having? X to the 5th. Okay. Now we're going to go on to the quotient rule. Okay, so open the quotient rule one. That's this one right here. Okay, so notice I'm going down the page. So now I'm doing the quotient rule. So the quotient rule, when dividing things with the same base, we can subtract the exponents. Okay, so basically that says we can take 3 minus 2 and get 1. So this would be x to the 1st. Now, always answering the question why is important so that you understand the rules and that you're not memorizing them, but understand them. So why does that work? Because x to the 3rd means I have x times x times x in the numerator. In the denominator, I have x times x. Well, anytime you take something divided by itself, you get 1. So x divided by x cancels to make 1. X divided by x cancels to make 1. How many x's do I have left? 1, and it's in the numerator. Okay? Now we're going to do the 0 power rule. Okay? So now we are on to the 0 power rule. It's the last one on the left side. Okay, so 0 exponents. Okay, anything to the 0 power is 1. So x to the 0 power is 1. 45 to the 0 power is 1. Well, even Brendan to the 0 power is 1. Okay, So anything to the 0 power is 1. So let me ask you why. Well, remember we just got done with the quotient rule. It said if the bases were the same, you can subtract the exponents. What's 2 minus 2? Yeah, that's x to the 0. That's 1. Another way to look at that is, what's anything divided by itself? 1. There you go. So this turns out to be 1 no matter what. All right. Now we are going to go ahead and go up to the top right, which is negative exponents. Okay. To make a negative exponent positive, you move it to the other side of the fraction bar. So if it's negative in the numerator, you put it in the denominator. If it's negative in the denominator, you move it to the numerator. Okay, so this is all over 1. This is in the numerator. So to make it positive, I put it in the denominator. All right, how about 1 over x to the negative 3? Well, it's negative in the denominator, so I put it up to the numerator and it'll become positive. Okay, there is a little trick, or not a little trick, I'm sorry, something that you want to be careful of. Say I had negative 2x to the negative 5. I get a lot of people wanting to move the negative 2. This only works with exponents. Negative 2 is a coefficient. Okay, you can't move coefficients. Okay, the only thing you can move is the base with the exponent. So the answer to this problem would be negative 2 over x to the positive 5. Okay, do not get in the mistake of thinking you can move the 2 down to the bottom and make it positive. Negative 2 is nothing like 1/2. And that's what you would say. You'd be saying that negative 2 is equal to 1/2. Wrong. It's not. Okay, so make sure you're only moving the exponent on that one. All right, now we are going to do a power to a power rule, or a power to a product, basically a power to multiple things. Okay, so you're going to distribute the exponent to everything and multiply the exponents together. Okay, so this basically says if you have a product here, as long as it's not being added, okay, that's different. This is a product, so we have two things multiplying together. We can say 2 gets the power of 3, and x squared gets the power of 3, which means 2 to the power of 3 would be 2 to the power of 3, and these two would be 2 times 3, which is 6. So a power to a power, and we multiply. A power to a power, and we multiply. Okay? And the reason why this becomes just a 3 is because if there's no exponent there, there's actually a 1. So why does this work? Okay, well, this means 2x squared, 2x squared 3 times. All right, so let's write 2x squared 3 times. How many 2's do you have? We have 3. How many x's do you have? Well, you have 2 here, and 2 here, and 2 here. That makes a total of 6. All right, so a power to a power, and we multiply. And everything in the parentheses needs the 3. That doesn't work the same when we do x plus 3 squared. X plus 3 squared is not x squared plus 9. It is not that, okay? This only works when we have factors, not terms. Another, those two words coming back again. Okay, the next one is a power to a power, but we have division. So we've got a quotient, basically, and everything's to a power, okay? So same rule. Everything gets the power, because a power to a power, and you multiply, okay? So it would be 4 gets the 2, X squared gets the 2, and y cubed also gets the 2. So 4 to the 2 would be 4 to the 2. X to the squared, power to a power, and we multiply. And then this would be y to the 6th. 3 times 2 is 6. You can also say that 16x to the 4th, y to the 6th. Just like on that last one, you could have said 8x to the 6th. That would work too, okay? All right, so those are the rules we need to remember. And now we're going to do a bigger example. Okay, so we got a couple of rules in here. We have, we got the division, we got a power to a power, we got a y to the 0, we got a negative. Okay, so what I always do is I start by simplifying the inside. Okay, y to the 0 is 1, so just like it cancels out and makes a 1. Well, 1 times 4 would still be 4. I don't like x negatives, so I'm going to move that down because it's in the numerator. I'm going to move it down to the denominator. When I move it to the denominator, okay, it becomes positive. Now, how many x's do I have in the bottom? 6. That's correct. The y to the 3rd just stays in the bottom. And now I'm going to take that to the power of 2. So now it's 4 to the power of 2 over y cubed squared times x to the 6th squared. So that becomes 16 over y to the 6th, x to the 12th. I always try to simplify before doing the power out here. That'll be the second thing I do. Simplifying is the first. Now, could you go ahead and raise everything to the power of 2 and then simplify? Yes, definitely. Not the choice I would make, but definitely can be done that way. Well, thanks for listening and taking good notes, and we will see you tomorrow. Peace out.